Assalamu alaikum everyone. My name is Mohammad Shahroz Nini and today I'll be presenting a research paper that I chose for my assignment. The title of the paper is From Data Warehouses to Streaming Warehouses, a survey on the challenges for real-time data warehousing and available solutions. This paper was published in the International Journal of Computer Applications in November 2013 and the authors of this paper are REVATHY, SARAVANA, BALAJI.B and N.K.KARTHIKEYAN, and they originate from India. The purpose of this research article was to look into the various challenges and obstacles involved in building a real-time data warehouse and some of the solutions available to overcome those challenges. So for introduction, data warehouses are typically designed for efficient processing of large amounts of data, and today many business applications are generating fast, multiple, continuous and time-varying data streams which are not manageable from the available ETL technology nowadays. So with the increasing globalization, with the increase in the number of businesses, with the increase in demand, today's businesses need to incorporate real-time data for continuous informed business decision making. And about this article further talks on how with the passage of time data warehouses have shifted from being offline traditional decision support systems to becoming real-time systems and hence speeding up the ETL and OLAP processes. So, a decision support system. A decision support system is an information system that supports business or organizational decision-making activities. A decision support system works on the data that is obtained, and it helps the user to make business decisions. Decision making is a crucial part of any business which determines how successful and competitive a business is in today's world. So the advent of decision support systems came in the early 1970s, and business decisions are based on that data that is available, that is analyzed according to predefined business requirements, and all this data is stored within a data warehouse, and this warehouse stores that data for a data-driven DSS. So basically all decisions that are made are based on the data, based on the analytical processing, the statistical processing that is performed on that data. Beginning in about 1990, data warehousing and OLAP, that is the online analytical processing, began expanding the horizon of DSS. So what's a data warehouse? According to Bill Inman, who is often known as the father of data warehousing, it is a subject-oriented, integrated, time-variant, and a non-volatile collection of data. It usually contains historical data that is derived from transactional data of an organization, of a business, and the data available within the data warehouse can be queried by users to perform analysis on. The growing need for real-time data has caused a change in the data-driven decision-making process. So basically, here we have a simple structure of a data warehouse where in the first layer we have the data sources. This can be any flat files such as Excel files or any of the media files. Then all the data from the sources go into the data warehouse where the data is stored, where all the processes are performed on the data, and then the data is available in the warehouse for the users for reporting, for analysis, etc. So the business markets around the globe are weighed down with rapid changes, and to cope up with such a business market, to cope up with such rapid changes, business level decision making must also be very quick. So data-driven DSS is now shifting from database management systems to data stream management systems. A data stream management system is programmed to manage a continuous stream of data. So basically it manages a data stream which is a real-time, continuous and ordered sequence of items. Traditional data warehouses employ a store and then query data processing model. which basically means that they first store the data and then perform the queries on that data. But here in DSMSs, monitoring applications register continuous queries which continuously process data streams looking for data items that are required by the user. So basically it's a continuous process in the data stream management system as compared to in a traditional data warehouse. That is the data warehouse management system, database management system. So here are a couple of differences between a DBMS and a DSMS. DBMS is a collection of non-volatile data, random data access, one-time queries, unlimited secondary storage, low update rate, no time requirements. In contrast with the DSMS, which is a collection of volatile data streams, sequential data that keeps rolling in, and you can perform continuous queries on that data that is coming in. But it has limited memory but has a continuous data update rate and real-time requirements. Stream warehouses. A stream warehouse is a data stream management system that stores a very long history that can go into years or decades of data. It's also a data warehouse that is continuously loaded with data. Now, many systems generate data in streams. A few examples of such streaming systems are stock trading companies, network monitoring systems, and traffic monitoring systems. Now, data stream management systems provide real-time analysis by processing the events currently in memory over a short time frame. Users would also require long-term analysis of data over large time frames. So there are short-term requirements and there are long-term requirements for which are required by the users. So a stream warehouse essentially bridges that short-term versus long-term gap by loading data continuously in a streaming fashion and warehousing them over a long period of time. So this caters to the user's short-term requirements as well as the long-term requirements by continuously streaming data over a long period of time. So this paper also further focuses on the traditional ETL. It tells us about the traditional ETL process that is being used nowadays. So the first step is extracting data from the staging area. A typical data warehouse system consists of a staging area where the data from the different sources are brought together. Now the data from the staging area is integrated, cleansed, and transformed. That is the transformation part of the ETL process, and then that transformed data is then moved to another database, which is usually known as the warehouse, where the data is modeled into tables called facts and dimensions. This is a three-step process, and the most recent data is pushed into the data warehouse database using this ETL process. Now the challenges we face in the traditional ETL process is that almost all ETL tools and systems available in the market today operate in batch mode, and for this batch process, the data should be available in an extract file in a specific format. This data will be taken up by the ETL process and transformed according to the business requirements and the business rules, and then is loaded into the warehouse database. Now this operation usually requires the data warehouse to be offline, but for a real-time system, if we want to employ a real-time data warehouse, even a small amount of downtime is not acceptable, and the more amount of incoming data, the more will be the usage of the data warehouse. So we cannot afford the system to go down for any period of time. So to overcome this, this paper proposes some of the approaches, and some of the approaches as to how the ETL systems can be modified to perform real-time or near real-time warehouse load. So some of the approaches are the first approach the paper focuses on is the near real-time ETL approach, which necessarily states that to not perform the ETL process, in turn The system refresh period can be shortened to a daily or maybe an hourly basis, and this will provide access to fresher data instead of going through the whole ETL process. This will save a lot of amount. This will save the user plenty of time, which is spent on the ETL process. So basically, the first approach is to not perform the ETL process at all, but to shorten the system refresh period. The second approach the paper focuses on is real-time facts, where as you know that a data warehouse maintains two types of tables, that is the fact tables and the dimension tables. So in most cases the actual querying happens on the fact tables. So the second approach would be to create a separate partition for the fact tables for the real-time data, so that fact tables in real time can be inserted or updated. And some examples of real-time data loading packages include data mirror and meta matrix. And for systems based on latest Java technology, Java messaging service can be used. So this was the second approach, that to just create a separate partition for fact tables for the real-time data, so that only fact tables are used in querying and all. The third approach is a trickle and flip approach, where staging tables are created that are the exact replica of the warehouse tables, and the data is stored in the staging tables, and these tables are periodically swapped with the actual warehouse tables, thus providing up-to-date data. So the data is continuously loaded into these staging tables, and these staging tables are then replaced with the actual data warehouse tables. So this is a constant process, which then also provides up-to-date data. The fourth and the last approach this paper focuses on is to create an external real-time data cache, where the real-time data is stored, and it acts as a separate instance of a database, and this basically is an in-memory database and is beneficial when fast queries are required and large amounts of data are involved. So data warehouse systems dealing with large volumes of real-time data, or those that require extremely fast query performance, can benefit from using an in-memory database, or in other words, an external real-time data cache. After these approaches to improve the ETL process, this paper focuses on real-time business intelligence. Data mining or OLAP tools are used for all the data analysis. The analysis of the data that has been extracted, transformed, and loaded into the warehouse tables can be done by these tools by data mining and OLAP. OLAP allows users to query database and then analyze the data, and they aid in preparing reports, and based on those reports, the users then make their business decisions. These reports usually include dashboards, which consists of different graphs, different stats showing how the business is currently doing. These reports are used by the managers to make business decisions. One of the methods proposed by this paper for real-time business intelligence is to stream data in real time from the source systems to the data warehouse, and that is done by stream analysis engine. So the goal of the stream analysis process is to extract crucial information in real time and then have it delivered to appropriate action points, that is strategic or tactical. It performs an in-depth analysis on the incoming data to identify interesting patterns. Query processing is done on continuously arriving data streams, and the drawback in this architecture is again the performance of the data warehouse. Continuously running queries may reference data in the database and have an impact on the near real-time requirements. So basically, when the system is continuously running queries, it may have a performance impact on the other requirements of the system. So there are certain problems Customary data warehouses are refreshed with the latest available data only on a periodic basis. So that period of refresh ranges from weekly to daily. So the analysis happens on terabytes of data, but the most recently arrived data will not be available within the data warehouse. That is the problem with customary data warehouses, with traditional data warehouses. Data stream management systems, however, support analysis on the latest available data in real time, but the amount of data on which the analysis can be done is very limited. So there are two problems. One is that the most recent available data, most recently arrived data is not available, and the amount of data on which the analysis can be done is very limited. So the solution to this is a streaming warehouse, which then combines the historical analysis of a data warehouse and the real-time analysis of a data stream management system. And the goal of this streaming warehouse is to propagate new data across all the relevant tables and views as quickly as possible. If the most recent data is available in the warehouse immediately, then analysis can be done on the latest data and business decisions can be taken accordingly in real time. तो आपके पास अगर recent data available है, then the analysis can be done. So this marks the conclusion of the paper. As enterprises such as the e-commerce market, the e-commerce stores that are increasing day by day, they're increasingly facing the need for real-time business intelligence and predictive analytics. The need of the hour is to build ETL tools to cater to all those needs, which will provide real-time data into the data warehouses. The underlying technology components and custom solutions for real-time data warehousing are excessively expensive. So this is the trade-off between the cost of real-time data warehousing and the actual requirement. So this is the trade-off between the actual requirement, which calls for serious research and consideration. Otherwise, the resulting system may have prohibited costs associated with it. So the importance, complexity, and criticality of such an environment make real-time BI and DW a significant topic of research and practice, and therefore these issues need to be studied beforehand before designing a system. That is. So that's it for today. That's it for my presentation. Thank you.